Hi and welcome. In this particular video, we are going to see top 25 questions that are asked in Goldman Sachs interview round. Yes, you have heard it correct. Top 25 questions. I will share the link where you can find these top 25 questions. You can also see that in this particular screen. We have added questions company wise, fine, and we'll keep on adding the questions company wise in this particular link. I will share the link in the description box below. Fine. As you can see here, while we scroll down, you can see we have a card for Goldman Sachs. And this is what we are going to discuss today. Fine. You guys can go and solve these questions, practice these questions to get prepared for the company interviews. I've already discussed, okay, what are the major ways to get inside any company in Amazon's video, Google's video, Microsoft's video. The general ways remains the same: off campus, on campus, through your networks, or hackathons, or coding contests. These are the general ways. I will share the links in the description box. You can find the links here as well. Fine. So I'm not going to repeat that again. Fine. Here in this particular video, we are just going to see about the coding questions. Okay, we'll discuss some of these coding questions, how you can present your answer in the front of an interviewer, and what are the ways to solve the coding questions. Okay, so let's directly deep dive into these things. I hope you guys will practice all these coding questions after I have discussed few of them. Fine, so let's get started. So the first coding question that we are going to see is unique frequencies. So first of all, let's read out the problem. You are given an array A of n integers. The task is to determine if the value of the frequency of each element in the array is unique or not. We need to print yes if all the elements frequency is unique, else print no. Okay, go and try this particular question. Okay, for the questions that I am discussing, I am adding the link in the description box. Go and try the particular question right now. Okay, try if you can solve this. Okay, what is the time complexity of your code, whether you are able to think of the optimal logic or not. Fine. Okay, so in this question it is talking about frequencies, whether frequencies is unique or not for every element. Fine. So for those guys who know frequency array, or you guys can use map. Okay, it's not a difficult question, it's a very easy question. For those guys who do not know what is frequency array, please learn the concept of frequency array. Fine, I'm just going to discuss the questions here, okay, and how you can approach them. But you need to learn the concept of frequency array. It's a very basic concept and it is used in many code. In many codes. Fine. Now let's suppose we have an array like 1, 2, 6, 2, 5, 3, 3, 3. Okay. And let's see what is the frequency of each character, of each element. 1 is coming 1 time, 2 is coming 2 times, 3 is coming 3 times, 5 is coming 1 time, and 6 is coming 1 time. Okay, so we have the frequencies of every element. Are the frequencies unique? Just think about it. Are the frequencies unique? No, frequencies are not unique. Why? Because 1 also have a frequency of 1, 5 also have a frequency of 1, and 6 also have a frequency of 1. These three have the same frequencies. So therefore frequency is not unique. Fine. So therefore this particular test case, the answer is no. You first need to understand it, and we need to understand it using the test cases. There is no other way. Fine. Frequency, if you get 1, 2, 2, let's say 3, 3, 3, correct? 4, 4, 4, 4. Now here the frequencies are unique. 1 is coming 1 time, 2 is coming 2 times, 3 is coming 3 times, and 4 is coming 4 times. Fine. So here the frequency is definitely unique. Okay, in this question also we can see the sample test cases. Fine. 5, 6, 7, 7, 6, 6, 6. 5 is coming 1 time, 6 is coming 3 times, 7 is coming 2 times. So first one is yes, second one is no. Sample test explanation is provided. Fine. So you have understood the question. If you know frequency array, using 2 frequency arrays you can solve these questions, correct? Now if you do not know frequency array, fine, then how to approach this? Then you have to use 2 loops here. Fine. Whether how many times you need to count every time. Now If you do not know frequency array, please go and learn it. Now in the front of an interviewer, when such a question arrives, okay, obviously the interviewer is expecting you to solve this question in an optimal manner. He will also ask for the time complexity. He will also ask for the space complexity. Fine. If you are using frequency array, so the space complexity is not constant. Okay, it's order of n. Okay, but the time complexity is also order of n because of the use of frequency array. If you are not using frequency array, then we need to calculate every frequency and you need to store it in different variables, or you need to use two loops. Yeah, you got देना. Fine, you got देना if you are not using frequency array. So you also need to understand कि time complexity कैसे calculate करते हैं, space complexity कैसे calculate करते हैं. They are very important concepts for the interview. Okay, then the interviewer will maybe ask you to explain your approach. Fine, so you will explain the approach that first we will store all the frequencies, all the character frequencies in a frequency array. Okay, like we have already done here. Okay, that 1 is coming 1 time, 2 is 3 is coming 3 times, 4 is coming 4 times. Now we have the frequencies. Now how we'll check whether the frequency is unique or not? Okay, obviously you guys can use hash maps here. Fine, I'm just explaining this with the help of frequency array. Now how to do that? So once we already have the frequencies, now we need to calculate if the frequency is unique or not. Can't we use one more frequency array? We can use second frequency array as well. Okay, now in the second frequency array, we'll store the frequencies of the frequencies. Correct, frequencies of the frequencies. So here we will say that frequency 1 is coming 3 times, frequency 2 is coming 1 time, and frequency 3 is coming 1 time. So they are not all ones, correct? So that means they are not unique. Every value should come only 1 time. So here you can say frequency 1 is coming 1 time, frequency 2 is coming 1 time, frequency 3 is coming 1 time, and frequency 4 is coming 1 time. All are ones. So we will print yes. If any one of them is not 1, it is greater than 1, then we will print no. That's it. That is the algorithm to solve this question. Correct? Required knowledge is use of hash maps or the use of frequency array, whichever you find more comfortable. Fine. If you do not know what is frequency array, please learn it. Fine. It's readily available on the internet. Okay. Fine. Let's move to the next part. Now the next question that we are going to discuss here is pivot index. Okay, the link is provided. First please go and try to read the problem. Try to read it on your own. Okay, try to create some test cases, try to create some logic, try to create some algorithm out of it. Fine. There are two parts. First is to solve these questions in some space complexity. That means you can use order of n space or more. But there is a follow-up also. Solve this question without using much space complexity, in constant space complexity. You cannot use any extra space. Fine, to two parts. Okay, interviewer may first ask you just to solve this question normally. Means time complexity should be optimal, but you are allowed to use extra space. Once you give this particular approach, then the interviewer may follow up. Now try to think of a logic without using extra space. Fine. This is how it can go. So first try to read. Okay, pause the video, go here, try to read the question. Try to understand it, try to solve it on your own. Okay, fine. I hope you guys have tried it on your own first. Fine. So if we go and read the problem statement, it is saying you are given an array A of n integers. The task is to determine the pivot index of the given array. The pivot index is defined as the index where sum of all numbers to the left of the index is equal to the sum of all numbers to the right of the index. Okay, it's pretty clear what the problem statement is saying. Correct? So we have, let's say 1, 2, 4, 1, 1, 1. So let's go and understand this particular question. Fine. 1, 2, 4, 1, 1, 1. Okay, the indexes we can keep here as 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Correct? Now, here what we can do is the sum to the left and the sum to the right for every index we need to calculate. Okay, what is the sum to the left of 0? Left of 0 index, that is 0. Sum to the left of index 1, that is nothing but 1. Sum to the left of index 2, that is nothing but 3. 2 plus 1 is 3. Sum to the left of index 3 is 4 plus 2, 7 plus 1, 8. Okay, 4 plus 2 is 6, 6 plus 1 is 7. It is 7. Fine. Let me rub it out and write it 7 properly. Then the next one is 7 plus 1, 8. And the next one is 9. Okay. So we now have the sum for every index left. Fine. Left elements of every index. Now similarly we can have a sum of every elements, right? Okay, to match. So what is the sum to the left of this? That is nothing but 0. What is the sum to the right of 4? That is nothing but 1. Sum to the right of 3, 1 plus 1, 2. Right of 2, 1 plus 1 plus 1, 3. Right of 1, 3 plus 4, 7. And right of 0 is 7 plus 2, 3 plus 4 is 7. This is 7. And 7 plus 2 is 9. So now we have the sum to the left of every index and to the right of every index. Now we need to print the index, okay, which have the sum equal. Fine. That is nothing but the index 2 in our case, because the sum is equal 3 and 3. Are there more conditions? For that you need to read the problem statement carefully. Okay, so let's go and read the problem statement. If you see the output format, it is given print a single integer denoted the pivot index 0 index space. If there is more than one pivot index, then print the leftmost one, so that needs to be taken care of. And if there is no such index, you need to print -1, so that needs to be taken care of. Fine. Now if we move here, for guys who have already know about prefix sum array and suffix sum array, you guys know how to solve this question in order of n space complexity. Okay, prefix array, prefix sum array, prefix sum and suffix sum. This is what we have calculated here. Correct? For every index we have calculated the sum previous to it, that is left of it and the right of it. For that we use something called prefix sum and suffix sum. If I just give you an example, 1 2 4 1 1 1. Okay, sum to the left is 0. Now what we are doing is we are adding 0 to 1 and writing it here. Sum to the left of 2 is 1. Now sum to the left of 4 is 1 plus 2 and we are adding it here 3. And 3 plus 4, 7. Okay, this is how it is going. 7 plus 1, 8. 8 plus 1, 9. Similarly for the suffix, that is from the end, so we have added it from the end. 0, 0 plus 1 goes out to be 1, 1 plus 1 is 2, 2 plus 1 is 3, and 3 plus 4 is 7, 7 plus 4 is 7 plus 4 is, sorry, 7, 7 plus 2 is 9. Fine. So you need prefix sum knowledge and suffix sum knowledge, again very important concept. Okay, that is been used in many different logic. Fine. So using that, this particular question is very simple, correct? If you know this, if you understand how to use these two concepts. Fine. After that you just need to traverse both the array, find the equal element from the left. As soon as you find the first index where both the elements are equal, you need to print it, because it is saying we have to print leftmost one. Fine. If you do not find any element equal, the answer is 0. The answer is -1. Correct? Fine. So now you know the concept used in this particular question. Okay. So first you discuss this particular concept and the logic you have thought of with the interviewer. Now interviewer will ask a follow-up question if he wants, that solve this without using the prefix and the suffix sum. Okay. Now if we need to solve this without using prefix and the suffix sum, fine. But also the time complexity should remain same. Okay. So can we have prefix and the suffix sum without using extra space? Can we do that? Without using extra space. Think about it. Pause the video and think about it. Okay. Just by using some variables, what is the left sum and what is the right sum, can we think about it? Just think about it. Because suppose if I'm starting a variable, an index I from the left and index j from the right. Okay, but the thing here is, when we are using prefix sum, 3 here is coming at the second index, that is 0 1 2, correct? But from this position, if I talk about position, it's the third position, correct? But from the right, it's the fourth position. The positions are not equal. Okay. So how to do this? How to move forward here? Can I just use a single index I and calculate what is the left sum and the right sum? And as soon as I find the sum equal, we just print I, because we need to print a single index. We cannot print two indexes. Okay. I've given you hints. Try to solve this question on your own now. Okay. Okay. I hope you have paused the video and tried it. So here what we are going to do is we will have a left variable and a right variable. Fine. Now we know that at index I equals to 0, the left sum is 0. So we'll initialize it with 0 every time. And the right sum is 9. What is actually 9? That is nothing but the sum of all elements to the right of it. That is nothing but the total sum minus the sum of the first index, correct? So the total sum minus the sum of the value of the first index, that is the 0th index, the first element. That is right, that is nothing but 9. So now we have in variables, not in array, sum 0 and sum 9. Obviously they are not equal, and here I value is 0. Correct? Now, moving with I value equals to 1, what is left? Left at I value equals to 1 is 1, that is nothing but we are adding in left array of I minus 1. Correct? This is what we are doing in the prefix array also. 0 plus 1 we get 1. Fine, so I value is 1, we are adding I minus 1 value. That comes out to be 1. And what we are doing in the right? In the right, we have to subtract the next value 2, because right of 1 is nothing but all the values on the right minus all the values on the left, or from till that particular point. Fine, so right minus equals to array of I. That is nothing but 9 minus 2, that is nothing but 7. So we get now 1 and 7 without using prefix and the suffix array. Now when I value becomes 2, L value will become 1 plus 2, that is nothing but 3, and R value will become 7 minus 4, that is nothing but 3. And as soon as we get left equals to right, we will stop and return and print I equals to 2. If we never get left equals to right, then we will print minus 1. That's it. This is without using suffix and the prefix array. That means using left and the right variable only. Okay. We found out these values. These values we needed to find out. So 0, 9 we found out. Then 1 and 7 we found out. Then 3 and 3 we found out. And for that, for the right part, what we did, from the total sum, we kept on subtracting what is required. That is from 0 till that particular point, we kept on subtracting that sum to get the right value. Left value was very simple. It's normal traversal. Fine. Okay, so this was the second way to solve this particular question without using extra space. Fine. So now try to implement this. All the very best. Now we will move forward to the next part. Now let's look at third question that I am going to discuss. This is the last question that I am discussing. Rest you guys need to practice and solve as much as possible. Fine. So that is all possible balanced parentheses. The question says you are given a positive integer n which denotes the number of pairs of parentheses. Okay, so this is a pair, closing bracket, opening bracket. Okay, sorry, opening and closing is a pair. The task is to determine all combinations of well-formed balanced parentheses. Fine. So for example, let's see an example here. Okay, so if n value is 3, okay, so we need to find out all well-formed balanced parentheses. What is the meaning of balanced parentheses is there is a closing bracket for every opening bracket, and the closing bracket should not come before that particular opening bracket. Fine. So for example, for n equals to 3, we have 3 opening brackets, 3 closing brackets. Okay, we have pairs, it's well formed, balanced. We have this one. Okay, this is also balanced. We have this one. I guess we can do like this. Just a second. Yeah, like this we can do. We can do like this. This is also well formed, balanced. Fine. And this is also well formed, balanced. Okay, so we need to find out every possible balanced parenthesis sequence for a given value of n. Fine. So in the test case also they have provided for n equals to 3, we have 1, 2, 3, 4, 5 possibilities. So whenever we say that you need to find all the possibilities of something, that means recursion backtracking. Correct? Because we need to find all the possibilities. There is no need to minimize anything. There is no need to optimize anything. you just need to find every possibility. So think of recursion backtracking at that particular point. Fine. If you do not know how to dry run recursion, or actually how the recursion works internally, okay, watch this particular video. Fine. It is about dry running recursion, how to dry run recursion, and it will clear your concepts of recursion a lot. What is happening inside the calls of recursion? If you are not aware of it, please watch this before moving forward. Fine. Now, let's see how to solve this question, how to create all these parentheses. Fine. Obviously, it's recursion. Okay, it might take some time. Okay, but do watch the video throughout. If you are liking this particular video, do consider liking the video and subscribing to our YouTube channel. Fine. Fine. So moving forward now, we have n equals to 3. That means we have 3 opening brackets and 3 closing brackets. Fine. Using 3 opening brackets and 3 closing brackets, we have to form a particular sequence. Okay. So when we use an opening bracket, suppose we use an opening bracket. So now we have only 2 opening brackets left. We use one more. We have only one opening bracket left. We have one more. We have 0 opening brackets left. Now only possibility is using 3 closing brackets. Okay. So as soon as there is no opening bracket left, there is no closing bracket left, we have to print the sequence that we have generated. So this becomes the base case of recursion, that whenever opening bracket is 0 and closing bracket is 0, whatever the sequence we have generated, print that particular sequence. Fine. So that becomes the base case. Now moving forward, if we have an opening bracket, because closing bracket cannot come before opening bracket, correct? So if we have an opening bracket, we need to put it. Okay, so if the opening bracket count is not equal to 0, so if we are using a string to make the sequence, in the string we need to add an opening bracket. Fine. And we need to now call the recursion function. Okay, whatever the recursion function that we are using, we need to call it. We need to reduce the count of the opening bracket, and the closing bracket remains same, the count, and we need to pass the updated string. Correct? This is one way what we are thinking. Fine. Or there is one more thing. If you have seen the video of dry run of recursion, you will understand this point, that suppose what I am doing here, I am not updating the string in this particular line, but while passing here, I am updating it. Okay, this is what we are doing, like this. So what will be the change? Which one is correct? If you have seen the recursion video, you will clearly understand this point, the dry run of recursion. These two are different. Here we are updating the string in a particular recursion call. Here what we are not updating the string in that recursion call. We are updating it for the next recursion call. Okay, this will have a huge impact when we return from the previous calls. Fine. Okay, now if opening bracket is not equal to 0, it's fine. But what if the opening bracket is equal to 0? Fine. Then what we will do? Should we keep on adding the closing bracket at that particular point continuously? Okay, but if that is the point, we'll not get different sequences. Means what about this particular sequence? Will we get these sequence? Because at this particular point, we have used just one opening bracket, and after that only the closing bracket arrives. Fine. So what should be the condition here if opening bracket is not equal to 0? What should be? Think about it. Pause the video and think about it. How will you move forward from this particular point? Okay, what should be condition to add closing brackets? That is the point. We have already added opening brackets. What should be the condition to add closing brackets? So you can make a recursion tree. Okay, it will help you out. So we have opening bracket count as 3 and we have closing bracket count as 3. Fine. So let's start creating it. So first of all, opening bracket is not equal to 0. We add a opening bracket in the string, count becomes 2. Again, recursion calls, O is not equal to 0, so we create one more. Again, recursion call, O is not equal to 0, we add one more, and now it becomes 0. Fine. So till now what we thought is, if O is 0, we can simply keep on adding C. Okay, keep on adding C. So we get one closing bracket, count becomes 2. Fine. Then we get one more closing bracket, count becomes 1, and we get one more closing bracket, and count becomes 0. As soon as this hits, we have hit our if condition, okay, the base condition, and we'll print this particular thing. Fine. Now after we print this particular thing, it will return to this particular point. Fine. So this was an opening bracket call, this was also an opening bracket call, this was also an opening bracket call. From this point onwards, it was a closing bracket call, closing bracket call, and closing bracket call. Fine. And for every call we have the values of O, C, and our string. Fine. So when we return to this particular point, okay, in this point O value is 0 and C value is actually not 0, it's actually 1, because 0 opening brackets are there but 1 closing bracket is still present. Fine. So when we return from this particular point, should we add that C? No, obviously we are not adding the C, we will get the same thing back. So we return back. We return back and we get O value as 0 and the C value as 2. Again, should we add it? No, we'll go to the same point. There is no point in adding. We go back. Now here O value is 0 and C value is 3. Again, no point in adding because we'll move in the same direction. Coming back, O value is 0. O value is 1 and C value is 3. So at this particular point, I have an O, I have a C. Should I add an O? No, because it will have the same impact if I add an O. Can I add a C? Yes, I can add a C. Okay, it will give me a different string. So there is a case that if O is not 0, then also we are adding C. Keep this in mind, very helpful, it will be helpful. Fine. Moving forward. Now in this particular scenario, our O is remaining, 1 O is remaining and 2 C is remaining. Fine. Now my point is, if I add a C again, suppose I add a C again, okay, so my O is 1 and my C is 1. Okay, now what should I do? If I add a C again, it will not work. Why? Because I cannot use a C before using a O. Understand this point. Okay, there is one O remaining and one C remaining. At that particular point, if I use a C, okay, O value will be greater than C, but that means I have not used an opening bracket, but for that I have already used a closing bracket, so I cannot do it. So if my O value is greater than C, this condition should never happen. Condition is if O value is less than C, then I can use my closing bracket. But if O value is greater than C, I cannot use my closing bracket. Fine. What about equal? This case is equal, where it will come. Pause the video and think about equality. Make this more conditions and pause the video to think about more equality. So if O is 1, C is 1, can I add a C? No. In this case, it is saying that if O is greater than or equal to C, do not add it. Only if O is less than C, then only add it. This case is saying this. But can we have a different case that you need to think about it? Think about it, think about it, pause the video and think about it. So I hope you guys have tried it out. Okay. Now moving forward, till now what we have thought is that if in this part, if we go forward, that if O is 0, okay, and closing bracket count is also 0, okay, we have to return the string. We have to add the string in whatever array data structure collections we are using, depending on your language. Okay, because finally we have to sort it out, because according to the question we have to print this in lexicographical manner. Fine. If O is not equal to 0, open count is not equal to 0, then we need to add the open bracket. And if open bracket count is less than closing bracket count, then we need to add the closing bracket. This is what we have thought till now. Okay, because if it is greater than or equal to 0, we will not add it. Fine. So in this particular scenario, O is 1, C is 1, so we will be adding an opening bracket. Fine. So we'll add an opening bracket. Now O is 0 and C is 1, so in this case obviously we'll add a closing bracket and we'll get one more, what you say, string. Fine. And we will repeat this particular process. Fine. So if this is here, call the recursion function, add the opening bracket, reduce the open count by 1. Call the recursion function, add the closing bracket, reduce the close count by 1. Okay, whenever we come to this particular point in our recursion calls, according to our logic, it will work out. Fine. So this was about recursion. You really need to understand what recursion is, how it works. Okay, what happens in each of the recursion calls to understand this much particular better. So now go and try all these particular questions. Okay, all the very best, everyone. If you want us to cover these type of questions for more companies, do comment below. Okay, like, share, and subscribe. Thank you.